10.2 is about ellipses, and we will briefly bring circles back in towards the end as well. So an ellipse is a set of all points, the sum of whose distances from two fixed points called a foci is consistent. So with our ellipse, if we have, a horizontal ellipse, so first off, let's just say this is my center. That would mean my major axis is going horizontally. At the end of my major axis are my vertices. Vertically, I would have my minor axis. Notice that the minor axis is smaller than the major axis. And at the end of those are my co-vertices. So I'm going to go ahead and draw what it looks like, which is essentially an oval, but it's called an ellipse. Again, the longer of your two axes is called your major axis. At the end of it are your vertices. And there's one over here as well. The distance from the center to a vertex is called A. So my center is still going to be HK. If I have a horizontal ellipse, my vertices, so those are changing horizontally, so that's affecting your X, so H plus or minus A, so adding A to go to the right, subtracting A to go to the left, and then K for the Y, so I didn't go up or down. This smaller of the two axes is called your minor axis. The end of those rather are your co-vertices. The distance from the center to a co-vertex is B. So to find my co-vertices, since it's a horizontal ellipse, the H did not change, but the K I did plus or minus B, depending on whether I was going up or down. Finally, my foci fall on that major axis. The distance from the center to a foci is C. So my foci is, since it's going horizontally, H plus or minus C, and then K. Now we also have vertical ellipses. So I'm actually going to move this center information over here to where it's kind of in the center of both of these. Since it does apply, it is HK no matter whether I'm a horizontal ellipse or a vertical ellipse. So I have my center right here. This case, since it's a vertical ellipse, that major axis is going vertically. And at the end of each end of that axis is where my vertices are. Just like they were in the other ellipse, each vertex is a distance of A away from the center. If you look at this, whether I'm looking at the vertical or the horizontal, if from one vertex to the center is A and from the center to the other vertex is A, then the length of my major axis is 2A. My minor axis in this case would be going horizontally. Its length is going to be 2B because the distance from the center to an end is B, and yes, it still goes to those co-vertices. So my minor axis is 2B. Let's go ahead and get my points of my vertices listed off. So in this case it was vertical, so it is the Y value that's changing, so it's still going to be H from my center. My K is going to be plus or minus A. For my co-vertices, those are horizontal, so they're going to affect the x. So I'm going to do h plus or minus b, comma k. My foci will match up on that major axis again, closer to the center, but that distance is still going to be c. So you're going to keep your x the same with the h there, and then k plus or minus c for this. And c, no matter which way it's going, vertical or horizontal, for an ellipse is going to be a squared minus b squared. Now, let's look at what our equation is going to be for these. For my horizontal ellipse, it's x minus h squared plus y minus k squared, and they will equal 1. Now, if you notice I put these fraction lines here. Since it's horizontal in this case, underneath my x, I'm going to have a squared. That lets me know that that a that went with my major axis and my vertices was affecting the x, so it's horizontal. Underneath my y is my b squared. Over here is very similar. I'm still starting with my x minus h squared over something plus y minus k squared over something equaling 1. In this case, since it's vertical and the a major axis, vertices, everything is affecting the y, I'm going to put the a squared underneath my y. The b squared will go underneath my x. Notice that in both situations, c is actually not part of the equation, so when you're trying to figure out where foci go, you do have to use this c equals the square root of a squared minus b squared. One thing that's important to note, a is always greater than b. Always, always, always. So whichever one's bigger, that's going to be your a. Looking at this example, draw the ellipse and write the standard form of the equation of the ellipse with foci at 0, 1 and 4, 1 and major axis equal to 6. Take a second and go ahead and plot those points. Notice once you have those points plotted, it is quite simple to figure out where the center would be. So I do want to go ahead and write that down. My center is going to be 2, 1. And since I know the distance from my center to my foci is c, and that distance is 2, I know that c is 2. The other thing I know is that my major axis is equal to 6, which means the whole length across is 6. So from my center to one vertex is going to be 3. So I can put both of my vertices there. A is 3. Now to find b, I know that c is the square root of a squared minus b squared. So 2 is the square root of 9 minus b squared. I would square both sides. Get my b squared over here. 5 on this side, so b is just the square root of 5. Since it is going horizontally, my ellipse is essentially like this. Then I'm going to use x minus h squared over a squared plus y minus k squared over b squared equals 1. So x minus 2 squared over a squared would be 9, plus y minus 1 squared over b squared would be 5, equals 1. That is my equation for this ellipse. Draw the ellipse and find the center, vertices, and co-vertices, and foci. So I know that from both of my equations, when I looked back at this, they were both equal to 1 every time, so I need this to be equal to 1. So I'm going to divide everything by 36. So I have x squared, 4 over 36 would become 9 in the denominator, plus y squared would just be 1 over 36 equals 1. From there, my center, there's nothing with my x or y, so it's 0, 0. I'm going to have vertices, co-vertices, and foci. For that, I would go ahead and kind of graph it. So I have my center, If you recall, the bigger one is always a, so this guy is going to be a squared, which means that a is actually 6, and it's underneath my y, so I'm going to come up 6 and down 6. This guy is b squared, so b is 3. That's going to affect me horizontally because it was underneath my x. Preferably a little bit more rounded there on top. So my vertices, again, affected it vertically, so I have 0, 6, and 0, negative 6. My co-vertices affected it horizontally, so I have negative 3, 0, and 3, 0. For my foci, I do need to find c, which remember is the square root of a squared minus b squared. 36 minus 9 is 27, which you could simplify to 3 radical 3. So c is 3 radical 3. Your foci will fall between the center and the vertices, so those are vertical. So 0, and then I'm going to have 3 radical 3 and negative 3 radical 3. On example 3, you're writing the standard form of the equation of the ellipse and find the center, vertices, co-vertices, and foci. So you are completing the square with this. First thing we want to do is group all of our x's together. So I have x squared plus 6x. Group my y's together. So I'm going to have 4y squared minus 8y. And I'm going to go ahead and move that 9 over to the other side. Now, for my x's, there's nothing to factor out in front, so I'm going to leave those alone. You'll see why in a second. I'm leaving this kind of blank here. For my y's, I can factor that 4 out, and you always want to factor out whatever's in front of the squared term. So I'm going to have y squared minus 2y. And then I want to complete the square. I'm also going to put this guy in parentheses just so it stands out a little bit more. So to complete the square, you're going to take that b and do divide by 2. So 6 divided by 2 would be 3. And then I need to square that guy. So 9. So I'm going to add 9 on this side, and I'm going to add 9 on this side. Over here, negative 2 divided by 2 would be negative 1. Squared would be 1. So I added 1 to the left. Technically, though, because of the 4 out front, we did 4 times 1. You really added 4 to the left. So you do need to add 4 to the right. That is a very common mistake. So make sure you're not just copying it right over. If there's a number that's out front, you have to make sure you multiply. Now the whole reason we did this is x squared plus 6x plus 9 is x plus 3 squared. Y squared minus 2y plus 1 is y minus 1 squared. This number, here the 3, here the negative 1, is always whatever you got when you did that b divided by 2. So 6 divided by 2 was 3. Negative 2 divided by 2 was negative 1. And on the right side, negative 9 plus 4 would be 4. Last step, like I mentioned earlier, you have to have it equaling 1. So I'm going to divide everything by 4. So I'm going to have x plus 3 squared over 4 plus y minus 1 squared over 1. And yes, I would go ahead and put it over 1. That way you can see what it is. Equals 1. From there, I would like for you to find your center, vertices, co-vertices, and foci. I will write those up in just a minute. Do make sure you're actually finding those and not just copying them down, because that will be a crucial part of lesson checks and your test. This last one I actually want you guys to try on your own and then check your answer. You should have gotten x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. Check that. If you need to get more work from me, let me know for that. Circles are not new. Your equation is up there. It always equals the radius squared. I have these two problems as well as one other that I want you guys to go through. I am going to put the work up for these. It is your responsibility to check the work and see if you've done it correctly, but I'm not going to walk you through them as much since they're not new. Here's the first two. Make sure you check my answers and see where I plugged in everything to get my work. Last one, just make sure you don't leave it equal to 1.